Welcome to our first preview of our latest and greatest shore system. As you could see, in this version we now have rolling waves, much higher quality, shore foam and everything. So let's have a look at how it all works a little bit first. So you have your Gen 3 ocean actor. In this case it's Gen 4, but this system is available to the Gen 3 ocean actor as well. So it can be in our latest, more experimental ocean actor and the current one that you have. Next up, this is basically our new actor type called a shore manager. Now, shore manager has a bunch of options, so let's go over them and see what they do. The capture actors, and these tell us what's going to be generating the shore. We have our landscape, a sphere, and a couple of blockers. Now, blockers work a bit interesting. So for example, if you want to have an area where you do not have shore waves, well, look no further than this spot over here. What we've done is placed a really large cube. So let's see, block shore this. We have given it a custom stencil depth value of 2, and we have set it to render in the custom depth pass, and the ocean actor will and the shore actor will kind of take care of the rest. So next up, for default, you could see some of these settings here, which tells you which stencil value are we going to be using for our blockers. In this case, 2. Now we wanted to be able to sort of set this dynamically based on your project needs. For example, you might be using stencil value of 2 for something else, but this is where you can adjust it. Force update will generate all the shore data needed for your landscape to figure out where waves are. In this case, you could see that because we've included our sphere actor, it's also generating waves and everything, and it's looking pretty good. Next up, we have line thickness. This is just basically for the preview of the actor to make things a bit easier to sort of figure them out because they are massive. And next we have something really cool that's called mode. And if we open up this menu, we have a couple of these. Now, the basic one that we have at the moment is fully dynamic mode, and we're just going to go over these slightly later. Next up, you have resolution. We can run this really large sort of island at 512 resolution for render targets and all sort of generated data at very, very little performance cost. And in fact, for the time being, we recommend you sort of sticking with these capture sizes and resolution sizes. Next up, you have a water body. You're telling the shore actor which ocean actor is going to be working with. Right now we're selecting the ocean, and we have a few more parameters such as offset level, which we can adjust here, and it will sort of contract or expand the water, the shore, based on those. So you can see how we kind of pushed it all back. We're seeing a little bit more foam. And yeah, next up, something similar that allows you to further fine-tune things is the shore offset. Whoops. Which should ideally be done quite a bit less. So you can see we're kind of pushing off the shore. We're getting a lot more surf and sort of shore foam. Again, these are just meant to be used for small tweaks, as some really large values can break things. But you could see something really cool over here. You could see some of our layered effects. So we have actually 3 types of waves, which you could see here under shore parameters. But just to kind of demo them a bit more here, you have the rolling overall shore wave, which is this displacement mask. Then these large sort of swells are like gravity waves, and these are done through the parameters for over here, gravity waves. These are kind of like large surges that go over the land. And finally, you have the sort of breeze waves, which are these really subtle normal maps that just kind of go towards the shore. So let's just quickly revert these parameters. And to update it, we're going to hit the force update and we are good. What's really cool is that if you're using fully dynamic mode, all of this shore data is actually generated in real time in full dynamic mode. This means that it is something that will follow your player or point of interest character all over the map. So in our essence, this shore, this sort of level of quality is infinite in scale. But this is where the other modes sort of come in. For example, you may not want this, but you can do something like a static mode. So what this does is basically it will be updated once during play. All the capture and all the data will be generated just once. So for something smaller like this island, if this is your entire project, this is a completely viable approach to use. Dynamic set mode allows you to, dynamically set the shore data parameters. But what's really cool about this mode is that you can specify a pre-baked shore data set. So you won't have to generate all the shore data, but you could still have different shore settings. And these work by basically whenever the player enters the volume of the shore manager, it will set its shore data that's already existing, but you can have different wave parameters. So you can have islands with calmer waves or larger waves, but the shore data will be pre-baked. So this can save a bit of performance while still offering a lot of flexibility. Dynamic gen mode works in a similar way, but this time whenever the point of interest or the player enters the volume, it will generate the shore data, but only once. So you can still have multiple shore settings, but these can actually be somewhat updated in real time in case the world is somewhat dynamic or you have something like procedural islands. And the trigger volume extent is something that we usually like to set is this sort of outer box that should ideally be bigger than your shore manager, and that is when the player crosses this threshold, it activates all of these dynamic set modes and stuff like that. But in full dynamic mode this isn't used, as this whole thing will travel with the player. We're going to demo this in a second. So next up we have the shore parameters, and these are going to be affecting the overall visuals of our ocean. We have kind of separated these into a sort of categories to make things a bit more manageable. So at the top we have shore settings, and this will kind of tell you where the shallows range starts. So for example, we could push this a bit further or back. You could see it's flattening out the ocean a bit and the normals. You have the sort of blend of this, so how much it's being done. These default values are done pretty good, so ideally you shouldn't be messing with them too much, but you can make some small tweaks. Next, we have some really cool wind direction and wind influence. So right now our wind influence is 0, but if we go to this sphere here, it will make it quite obvious. We can set this to 1 and see that our shore waves now are coming from a single direction only. Like so. But for example, we still want to have some waves on the other side, so we can lower the influence a bit. And there we go. Of course, this direction can be changed. So we can have waves coming from another direction. And there we go. Next up, we have shore normal shift, and these are sort of the overall normals that are being used for the waves. Our rolling waves are based on the technology paper published by the Guerrilla Games for Horizon Forbidden West, so this is pretty much the workflow that we've used as well. Next up, you have things like shore, min-max blend, and this will kind of tell you how far these waves are kind of begin to form and stuff like that. Next up, you have the shore wave texture. This is the displacement for it, and you could control things like the animation speed, the panning speed, the offset, and a bunch of other things to really make your ocean your own. You have the amount of distortion that you can add to it, and next you have normals, normal quality, normal power, and everything, all these other good things. Of course, you have a little bit of a noise pass here that you can adjust to have the waves a bit more broken up or a bit more uniform, whatever you like. You have the power and the contrast of these. Next up, we have these little breeze waves, which let us just exaggerate a bit more over here. So they're like these additional normal maps that sort of come in. And of course, you could adjust the tiling, their speed, how harsh they are. And these are the sort of calmer waves that don't necessarily make any ripples and stuff, but add a little bit of nice extra directionality to your shore. Next up, the gravity waves. These are basically these large swells, and they create their own foam. And for example, let's see. Well, the simplest way to demo them is just to increase their speed. And you could see like these sort of larger surges that come from the shore. And these are fully independent from the speed of the other waves, which really adds a nice level of chaos to everything. And yeah, you can adjust how far they climb, how much of a flow they have in distorting the other waves, their speed, how far they climb, so we can increase the climb a bit. And you could see that they're really starting to take over our shore. This will kind of look better or worse depending on the overall landscape shape that you have. In this case, some of these rockier bits are not ideal for these waves, so I've kind of toned them down a little bit. Finally, you have the shore foam and the wave foam texture, which basically is your shore foam power. And yeah, you can see that it really blows up the foam for the shore waves if we start increasing these values over here. So let's take this whole thing for a spin. So now let's do like a quick demo of how the whole system works in fully dynamic mode. Over here we have a small render target that just shows us the ocean and the actors that we're capturing. So let's hit play and see what happens. Now initially nothing much, it will take a little bit for the initial build of the ocean, but afterwards it becomes pretty speedy and pretty much in real time. So there we go, we have our waves, and now as we travel we see that we're rendering more and more of our landscape, and some of our blockers you could also make out in that render target. But because we're doing this over such a vast distance, to be honest, we can afford to render out this sort of pass once every second or even once every 10 seconds. So really this is having almost no impact on performance whatsoever, as you could see. And as we travel, we see that the overall capture is traveling with the player, and more of the landscape is being revealed. So now, if we were to sort of hop out of this and back into editor mode, we could kind of take a look and see what's happening on the other side of the island. First, if we zoom out, we could see that vast quantities of shore are still being generated, but this is having little to no impact on performance. And really, we need to go over to this edge of the island just to see that, well, there's basically no shore being created here. But if the player moves closer to this area, in fact, let's quit out and simply launch the level over there. Like so. And we could see that now the shore is being generated here very quickly. And yeah, this pretty much allows our system to work on an infinite scale, or if needed, via the other modes on a sort of localized hyper-specific sort of values. Let's have a look at how buoyancy is handled. Well, let's just launch our actors. We're going to start with our ocean. Let's hit live ocean, and initially nothing will happen. And that is because we also need to run our shore manager. So let's force update it. And if you're launching the project sometimes for the first time, you will need to hit this button twice just to get the correct looking visuals. So, for example, let's have a look at how things are handled in terms of physics. So this is a little cube that we have over here, and we're just going to launch the level again. And we're going to exit. So, for example, we could see that this cube is close to the shore, which just has this sort of calmer area, and it's not being affected by the ocean buoyancy. But if we push it over here, we can sort of see it being moved and shifted via the waves of the ocean in a physically plausible way. But as soon as it gets close to the shore, it's having a much more simple floating physics. So how is this done? Well, it's kind of simple. Our ocean actor has been modified to have a slightly different buoyancy. So we have a couple of new options that shows here: use shore buoyancy and shore buoyancy object channel, and a few parameters over here. So what are these? Well, we're kind of telling it we use a secondary mesh. In this case, it is this really massive island mesh over here. Let's just visible hidden in game. And we've kind of created a low-res version of this island as a mesh. We have flattened it out, so we kind of squished it and then moved it slightly below the ocean. And oh, something you may have seen right now is now that we exited, our shore generation is a bit off. So what we need to do is just select our actor and force update so we can get more accurate visuals in the editor. But back to our shore mesh, we could see that right now it's just a flattened sort of gradient that goes deeper and deeper and shallows out near the shore. And what these parameters on the ocean actor basically do is that it does a secondary check from the distance between the floating object and this mesh. The closer it is, the less it is affected by the overall ocean displacement, and uses a flat water displacement to do that. For blend, you kind of, oh, apologies. So starting off with index, we're kind of telling which object channel this mesh is using, waterline, so we're not doing unnecessary traces. And if we go to our island mesh, sure enough, it's set up to be waterline. We need collision enabled. Realistically, we only need query. Only, there we go. For waterline, it should be set to overlap, and we really don't need any generate overlap events or things like that. What we do need is our tags called shore influencer. We also need our floating bits that we want to be affected by this to have a shore float component tag, and you could kind of see these in the waterline actor as well. We're kind of telling it, well, these are the tags that we're going to use. We've kind of moved to a system where you could use whatever tag you want, so you could change these as needed, but these are basically the default ones. So if we go back to our buoyancy, we're telling it we're using the waterline channel because this is the mesh that we're using as well. The shore blend will kind of dictate a bit of how this fall off starts working between the shallowness and the deep end. You could kind of tweak this a bit more. And the channels for the the tags, which the influencer is going to use, and that the float is going to use. And there we go. Now if we were to hit play, it takes a few minutes for the shore to update correctly. And there we go. Now, generally, this can be a bit distracting, so we don't really need to see it. So we can select our island mesh and just say, hide this in game. And there we go. So yeah, now that we've quit out once again, it might be worth to just update our shore, and we're seeing it all in action. And yeah, the cool thing is that all of this sort of shore generation data we can run in real time. So for really massive open worlds, you could use this system very much. We're still tweaking a few things. So the future plans will probably see some changes to visuals or more effects, more wave types. So yeah, overall, this is a good place to start. We have focused a lot on the optimization aspect of these waves and their scalability. So yeah, go make awesome things.